Alright, in this lesson we're going to be talking about identifying domain and range. By the end, you should be able to identify the domain and the range of a function or a relation, and then identify the domain and the range within a real-world context. Function notation, when we talk about domain and range, is going to be the way that we begin to represent our relationships here in algebra. We're going to be moving away from y equals, and we're going to be moving into what we call f of x equals. This is that function notation. The x is still going to represent all of your elements in your domains. These are all of the x values that you're already used to seeing. The big change here is that instead of y, what we're going to begin to see is f of x, and these are going to be all of your elements of your range, all of your y values. The important thing to know here is that when we talk about function notation, it is in slope-intercept form. So if you're working with an equation that is not already in slope-intercept form, you're going to have to move it into that form. When you're moving things into slope-intercept form, remember that you need to change the y to this f of x. We call this f of x. This is that function notation. When looking at domain and range, it's important to note that there are two types of ways that we're going to be listing our domain and our range. If our domain or range are continuous, this means that there's no interruptions. So here we have our graph here. There are no interruptions. There's a solid line connecting all of these points together, and so there's no gaps in our data. So we can list it or write it out as an inequality, as a kind of as a range of values. When we look at this other graph, though, this one off to the side over here, there are gaps, there are spaces in between our data. So these are specific points. And so we can't list every single value between, because every single value is not represented here. So we're just going to list those specific points. And so this would be listed in braces in that same way that we started listing our domain and range in that last video. So when we're listing domain and range as an inequality, a couple of things to kind of keep in mind. The first number in our inequality is going to be where your graph starts. And then the second number is going to be where your graph ends. If your graph doesn't end, then how we would express that is we would just write it with one number. So in this particular one, the x starts at 2 and the y keeps going. And so instead of having a second number, what we would have is x is everything that is greater than or equal to 2. The variable, if there are two numbers that we're looking at, the variable goes in the middle. And then remember from inequalities in 7th grade that if we want to include a point, we're using greater than or equal to. We're including, so we want the equal to part there. But if we're not including, if it's going up to that point, but it's not actually including that point, then we just use the less than or the greater than. And so just as an example here, this is from 7th grade when you were listing inequalities. 0 we wanted to include. So we wanted everything that was greater than or equal to 0. So this actually needs to be flipped a little bit, this greater than sign. And then everything that is less than 4. But we didn't want to include the 4 because it had an open circle. So that same thing is going to be true when we're talking about domain and range in algebra. Okay, so let's look at a couple of things. So here we have a graph that's continuous. We know that it's continuous because these points are all connected. We have one solid graph here. There's not gaps or disconnected points. So if we're listing the domain, this is that first one. The domain goes from left to right. So we start from the left, we stop at the right, and so one thing that might be helpful is to draw some lines from left to right. That way you don't get confused and focus from up to down, or from bottom to top. So we're looking from left to right. We see that our graph starts at 0. We see that it ends at 7. So we want everything that is greater than or equal to 0, but less than 7. Notice that the variable here, the x, is in the middle. And all of these values, because we're looking on the vertical or the horizontal axis, this x-axis, this is your domain. If we're looking at the range, okay, instead of being from side to side, we're looking from bottom to top. We always start from least to greatest. So the bottom number here is -2. That's the lowest it goes. The highest it goes is up to 4. And so our inequality would be from -2 to 4. Again, this value right here should say y. So we want y is in the middle of that variable, and all of these values are called our range. Okay, we want to determine the domain and range as a set of numbers and determine whether the relation is a function or not. So these top two graphs are discrete. So when we're listing out the domain, remember we're going to list them out in braces, and we're going to have a group for our domain, and we're going to have a group for our range. So looking at A, our domain, these are all of the x values. So this is -2, -1, 0, 1, and 2. Remember that we are writing them in order. And then we have our range, which is, again, in numerical order, -1, 2, 5, 8, and 11. So this would be our domain, this would be our range, and this is a function because none of the x values are repeating. When we look at the domain for the second one, again, we're listing out the x values, we're listing out the y values. Remember that there are 3 ones here, so we only need to list it once. Again, this is a function because the x's, again, we're looking at the x's don't repeat. When we're looking at C, this is continuous data. So this is data that we're going to write it as an inequality because we can have anything between, looks like -6 and 1. So we can have any of those values. If we're looking at a table, we assume that a table is continuous unless otherwise directed. So in this one, we knew that it was discrete because it told us that it was discrete, that we couldn't have those values. Or you'll know from the labels there if you can have fractional increments there. That's the biggest thing between continuous and discrete. It's continuous, you can have fractional pieces, whereas in discrete you can't. So for example, continuous, time is continuous because I can have fractional increments of time. But if I'm counting up the amount of clothing that I have, that is not continuous because I can't count half of a shirt. I either have a whole shirt or I don't have a whole shirt. When we're listing continuous, remember that you're writing it as an inequality. So this first one, move this table out of the way. So this first one, again, it starts at -6, but see there's this open circle here, so we're not going to include it. The variable goes in the middle, and you've got, and we know that it stops at 1. And so we know that all of the values between -6 and this should be +1 are included. And then our range, again, for range, we're going from bottom to top. Our range starts at 1 and it ends at 6. And again, the y is going to be in the middle here. And yes, this is a function because this would pass our vertical line test. For our domain for this table, it's always going to be all real numbers for this particular one. Now notice here that we have values that begin to repeat. So we're decreasing here. So we're going from 9 to 4 to 1 to 0, but then notice that these values start to repeat, so it starts to increase. This would give us, this type of graph right here would be our quadratic function. In a table we see those values repeating. So what you would look at here is that what value is in the middle. So the 0, 0 is in the middle of our table. This would start our range, and then everything is greater than that. So we don't need to do two numbers here. We would just need to say that y is greater than or equal to 0. So anything that is greater than or equal to 0. And again, yes, this is a function because all quadratic graphs are functions. Stating the domain and the range here, again, when we want to state the domain, we're going from left to right. So here it would be -5 to 5. The range would be -1 to 1. And then for our other graph, our domain is infinity to infinity, negative infinity to infinity, because the arrows are telling me that it's going forever in both directions. And then for our range, if we're going from bottom, it's a negative infinity, but it stops at 3. Last one here is that we want to look at writing reasonable domain and range. So here we have our equation. Our domain, when we're looking at this car's fuel tank, this car only holds 17 gallons. So for the domain, it can only go up to 17. So I can either put 0 gallons in or I can put 17 gallons in. We know that it travels 32 miles for each gallon. So if I put 0 gallons, it's 0 miles, and if I put in 17 gallons, then I can get 544 miles. So looking at that reasonable domain and range, what's the max that you can have? What's the minimum that you can have? Because we know that in real world situations, infinity is not typically an option. Again, we're looking at units as far as cups, and or units of vitamin D per cup. If you have a 16 cup jug of milk, you can either pour 0 or you can pour all 16 cups. Again, if you pour 0, you're going to have 98, or you're going to have 0 units of vitamin D. And if you pour all 16, then you'll have 1,568 units. Again, looking at that reasonable domain and range, what are your limits? So what does the word problem limit you to? Here we were limited to 17 gallons, and here we were limited to 16 jugs. Okay, before the next video, please consider the following question, or the following phrase. I can express domain and range as an inequality when it's blank because, again, subscribe to our YouTube channel, and I look forward to seeing you in the next video.